I see a lot of clients who use big int just simply because they want the biggest number possible. And that's great that you have visions of grandeur in your architectural design and financial success. But you don't need big int as an order increment column. Simply because int unsigned stores 4.3 billion values, which is quite a lot. So unless you're actually inserting and deleting rows excessively in a primary key, you should never hit 4.3 billion rows in one table. Now, you know, successful people have more than 4.3 billion rows in one table, that's granted, I've seen those systems. But you have other problems other than just putting them all into one row, into one table when you get to that particular situation. You will be partitioning and sharding your data in a different approach. So, I should put a caveat down there, big int is applicable. There are times when you are summing information and you want to store greater than 4.3 billion in the column. So, there is a purpose for it, but just defining big int auto increment for your primary keys is clearly a waste of 4 bytes. No big deal, but if your table has 4 or 5 foreign keys that are primary keys to other tables, and you have indexes on those columns, all of a sudden you can very easily cut your disk footprint in a column, in a table by 20 and 25%, just simply by changing big int to int. And don't forget the unsigned, because that gives you twice as many values if you still have those sites of grandeur. So what's the best practice? Well, one of them is to always define columns as unsigned unless there is a reason not to. You know, there are only 2 purposes for that. One, you can actually shove more values into the column than having it not unsigned. But just as another thing, one of the things very lax with MySQL is the data integrity in regards to that. MySQL prior to 5.0 with SQL mode would simply just throw you a warning. So actually defining the column as unsigned will ensure that non-negative values throw an error when you're using appropriate SQL mode in version 5, which you should all be doing. Other data type efficiencies. I guess I didn't talk more about decimal 31. Does someone want to throw out a reason why decimal 31 is bad? No takers?
No decimal amount.
Sorry?
No
decimal amount. Okay, well it has no decimal amount. But decimal is actually defined in MySQL as a fixed point number. So that means that it'll actually break up the column into 2 numbers to provide for arithmetic. So internally there will be a column to support 31 digits, and there will be another portion to store 0. So 0 is not relevant. So then we have to find a data type, a numeric data type that stores an integer value up to 31 bytes in length. It doesn't exist. So then it becomes a VARCHAR or char 31 field. So defining something as 31.0 actually turns out to be 32 bytes long, unlike what you would think would be just to store something. I still don't understand why they had decimal 31. There's some design architect who had it across the entire system.
Is decimal done as nibbles or bytes, or do you actually?
What happens when you define decimal before decimal point and after decimal point is it will choose the data type which is most applicable to the value that you have. So if you say, for example, decimal 4,2, then it's going to choose a data type for the 4 which can fit a value to store 4 digits. So anything up to 9999. So tiny int's not going to work, that's 255. Small int, 2 bytes, 65,000. So we'll define 2 bytes for that. And then on the other side you'll have 2 below, 2 after the decimal place. So it needs to choose a data type that can store a value up to 99, which is a tiny int. So decimal, 4,2 should effectively be 3 bytes. Don't quote me on that, but that's the principle behind creating the size for the fixed floating point. Here are some other things which may or may not affect your environment. Timestamp and date time are interesting ones. Timestamp was 4 bytes in length and date time is 8 bytes in length. So if you're just storing epoch values, the time which someone logged into the server, it's only going to contain a value that's valid for a timestamp column. And all the numerical functions all the date functions will be applicable to that. I should put a caveat on there in terms of time zone management. So these are principles, and like every principle in life, you need to understand and apply the principle and then learn how to break the principle. But in general form, if you still have date times, then potentially time stamp can be alternative. What is interesting in MySQL is a little point I put down there down the bottom. Date is actually 3 bytes and time is actually 3 bytes, but date time is actually 8 bytes instead of 6 bytes. So that's a question to stop the MySQL gurus as to ask why. I won't spoil the surprise. So you have to wonder what's the rationale there. You can come and ask me afterwards if you really want to know. Another thing which is very interesting is people will define columns as char when VARCHAR is used. A classic example is people define, VARCHAR char 100. They're using MyISAM. They're getting a fixed row format, which is great because it's more efficient than a dynamic row format. But they're only storing 10 bytes of information. So first of all, it could have just been char 10 instead of char 100. So again, your disk footprint can be larger. Yes.
My understanding, MySQL will automatically change char to VARCHAR.
For certain data types, yes, I believe you're right. In terms of smaller values, I guess one of the things I understand is that's true. I think that's actually true for other databases as well. But it's important that you design it to what you want. If you are storing one value in a column, then define it as char 1 because the schema by itself helps to inform the information of what's actually being stored. Where defining something as char 100 sort of implies, well, it defines you're going to put 100 bytes in there. Where if you're not going to put 100 bytes in there, VARCHAR sort of helps in the descriptive nature, but also helps in the underlying disk footprint. So as I've been saying, none of these are rocket science. They're all quite straightforward. But when you start talking at 200 gigabytes, a terabyte of data, and you can reduce it significantly, that cuts down the disk I/O. And disk I/O is the slowest portion in a large system when you don't have sufficient memory.